Everything Tesla has developed for its vehicles, the batteries, power electronics, advanced motors, gearboxes, software, and even the AI inference computer, is directly applicable to a humanoid robot. After all, the main difference is that instead of wheels, this robot has arms and legs. Tesla recently revealed that if all goes according to plan, the Optimus Gen 3X, expected in 2025, will be IP67 certified. This means it will have full dust protection and can be submerged in water for up to a minute without suffering damage. Now, imagine a robot designed for much more than just operating indoors. It will be capable of handling real-world challenges. In today's episode, we'll explore 5 reasons why Elon Musk believes the Tesla Optimus will become the benchmark for humanoid robots by 2025. And stay tuned, because the last reason will surprise you as much as it surprised us. Optimus' progress has been remarkable. At first, we only saw a person in a robot suit to illustrate the idea, but year after year, the progress has been impressive. Elon Musk has repeatedly emphasized that Optimus will be able to perform a wide range of tasks, surpassing the 1,000 distinct activities mark. And with constant software updates, that number could easily jump to 5,000 or even 10,000. The big difference in achieving this versatility lies in the most advanced robotic hands ever developed, designed to rival human dexterity. While a human hand can perform about 100 distinct movements, Optimus hands are already designed to perform at least 60 of them. In the past, the idea of having a humanoid robot that could perform everyday tasks seemed like the stuff of science fiction. After all, who would believe that a mechanical assistant would be agile enough to replace human labor? But Elon Musk has already demonstrated that Optimus can fold clothes, water plants, manipulate fragile objects like eggs or batteries, and even operate a computer. What's more, he can squat, jump, and move around offices with a surprisingly natural posture. Now, think about the practical application. In a clothing store, Optimus could fold and pack thousands of items per day, eliminating the need for human employees to do this. In the field, instead of complex irrigation systems, farms could use robots to water crops. And imagine an Optimus making breakfast, collecting eggs, and assembling sandwiches for the kids every morning. What once seemed impossible is getting closer and closer to becoming a reality, thanks to unprecedented technological advances. For all of this to be feasible, Optimus hands are one of the most critical aspects of the project, and they are a key focus for the Tesla team. Creating a robot that truly mimics human functionality is a huge challenge. That's why the new version of the arms now has 22 degrees of freedom, twice as many as the previous generation. Its hands are incredibly articulated and can move continuously, mimicking the natural movements of human fingers, something that no Tesla competitor has been able to replicate so far. The Tesla Optimus is currently powered by the Tesla AI 4 chip, the same chip used in the company's autonomous driving system. This processor allows the robot to analyze its environment and interact with it intelligently. However, when the commercial version is launched, it is expected to be equipped with a new Tesla AI 5 chip, which will go into production soon, making the Optimus even more capable and efficient. With the arrival of the new processor this year, the Tesla Optimus will see a significant leap in its capabilities, allowing it to perform an even wider range of functions. From industrial tasks and domestic assistance to disaster rescue operations, the robot is being designed to operate in scenarios where human work would be dangerous, repetitive, or tedious. What was once just a concept is now transforming into mass production. Elon Musk revealed that Tesla intends to manufacture thousands of Optimus units by 2025, starting with pilot deployments within the company's own factories. Production will ramp up rapidly, with the goal of reaching 50,000 to 100,000 units by 2026, with a potential 500,000 robots within 3 years. When it comes to the adoption of humanoid robots, price is a determining factor, second only to curiosity about their functionality. Currently, the average cost of a humanoid robot can range from $80,000 to $300,000, which may seem exorbitant to many. This high price is due to the complexity of the design and advanced technology that these robots require. However, companies like Tesla and Unitree are looking to change this by making humanoid robots more affordable. To prevent Optimus from reaching hundreds of thousands of dollars in price, Musk is committed to keeping its price around $20,000. This estimate puts Tesla's robot in a much more competitive position in the market. In comparison, the base Unitree G1 costs around $166,000, while the premium Unitree H1 starts at $90,000. With this price difference, many businesses and consumers may consider purchasing both the Optimus and other robots without major concerns about affordability. What makes the Optimus significantly cheaper than its competitors is Tesla's vertical integration approach. The company manufactures its own motors, batteries, and gearboxes, cutting out middlemen in the supply chain and reducing costs. In addition, by leveraging technologies already developed for its electric vehicles and the mass production model of the gigafactories, Tesla is able to significantly reduce manufacturing costs. Meanwhile, Unitree was able to reduce the price of the G1 by optimizing its design. Its compact size and less complex structure allowed for the use of smaller motors and fewer components compared to the H1 model. Despite the difference in dimensions, both robots have a similar weight. Furthermore, Unitree has reduced the number of wires, chips, and screws in its construction, which simplifies assembly and reduces costs. Another distinguishing feature of Unitree is the internal development of most of its hardware components, with the exception of the chips. This control over design and manufacturing improves performance and keeps the price competitive. The G1, with an estimated price of $116,000, is positioned as one of the most affordable humanoid robots on the market. This feat stands out even more when compared to models such as the Atlas from Boston Dynamics, which exceeds $200,000, and the Spot robot, sold for around $74,000. It is worth remembering that these prices are only estimates and may change as the robots get closer to commercial production. In the case of Optimus, it is speculated that its final price may be below $20,000, which would consolidate its position as the most affordable and viable option for various applications. The final price of the Unitree G1 could exceed $116,000, but it is still uncertain how these values will be defined in the market. Only time will tell exactly how much these robots will cost. Elon Musk has high expectations for the Tesla Optimus, especially for its autonomous learning capabilities within simulated environments. This process allows the robot to develop new skills and adapt before even entering the real world. This innovative approach significantly accelerates its learning, making it more independent. Thanks to this rapid adaptation, Optimus can adjust its movements instantly without relying on constant supervision. Whether assembling battery packs on a production line, handling household appliances, folding clothes, or even making a cup of coffee, Optimus refines its movements based on previous experiences, in the same way that humans improve their skills with practice. Although some descriptions exaggerate by suggesting that Optimus is fully autonomous, the reality is that it still requires some human intervention at the beginning to set up its tasks. However, once fine-tuned, it can operate almost independently, reducing the need for human involvement by an estimated 99%. Its neural processor is impressive, capable of performing an incredible 144 trillion operations per second. This enables advanced object recognition and real-time decision-making. What's more, Optimus's AI models are updated every 48 hours, ensuring it is always learning and continually improving based on the latest data it collects. To illustrate, while many people pay around $20 per month to have access to faster responses and frequent updates in AI applications like ChatGPT, Optimus does not follow this logic. It already comes equipped with a fully integrated system that updates itself, without depending on external interventions. Elon Musk's proposal with Optimus is to offer a truly self-sufficient robot, which does not require constant maintenance or concerns about manual updates. Unlike many other humanoid robots that still need to be operated remotely, Optimus was designed to manage itself. Its function is not to add more tasks for users, but rather to make their daily lives easier. Another major advance is in its hands, which are now capable of performing extremely delicate tasks, such as cooking, shoveling snow from sidewalks, and even bathing a child, according to Musk. The Tesla Optimus Gen 3 is equipped with advanced tactile sensors that automatically adjust the pressure and grip according to the needs of each activity. The idea of having a functional robotic assistant, like a real-life R2-D2 or C-3PO, who never gets tired or complains, is getting closer and closer to reality. Optimus is able to process information and respond naturally to the context in which it finds itself, whether inside a home or in a work environment. This is one of the most anticipated milestones in modern robotics. Optimus's gait has generated a lot of discussion in recent months. Most current humanoid robots have peculiar walking patterns, which have led to amusing comparisons, with some people joking that they appear to walk as if they had drunk several glasses of wine. However, these criticisms often ignore the complexity involved in engineering these machines. While at first glance, its stride may seem slow for certain functions, the reality is that its current walking speed, about 1 meter per second, equivalent to approximately 2.2 miles per hour, is more than sufficient for most tasks expected of it at this stage of development. It's important to note that Optimus' current capabilities do not yet represent its ultimate performance. Tesla aims to increase its speed to as much as 2.2 meters per second, about 5 miles per hour, by commercial launch. Since late last year, the company has been focusing on improving both the robot's mobility and dexterity. According to Milan Kovac, lead engineer on the Tesla Bot project, the team is working on several key improvements, including integrating a more advanced vision system for advanced planning, tweaking its gait for more natural locomotion on uneven terrain, increasing sensitivity to respond quickly to speed and direction commands, and developing techniques that allow the robot to fall safely and get up easily. These upgrades are intended to make Optimus not only more agile, but also more adaptable and reliable for real-world use. In one of the latest demonstrations, the robot was tested on uneven terrain, which received mixed reactions. At first, many mocked its unsteady gait. Even we found it funny. However, upon closer inspection, we noticed details that Tesla had not yet shared publicly. One of the main questions that arose was, why does Optimus not walk completely upright like a human? Why does he seem to have his knees bent, as if he were moving slowly? These questions led some to question whether investing in such a robot would be worth it, or even to suggest that Tesla should focus solely on producing electric vehicles. We admit that, at first glance, we had the same doubts. However, as we watched Optimus advance and Tesla's recent updates, our view has completely changed. A recent video showed the robot climbing a slippery and uneven slope, highlighting two crucial aspects: its ability to adapt to the terrain and the way it adjusts its movements to balance itself. According to Tesla, this was Optimus' first test on such a challenging surface, a type of terrain that even humans have to be careful when walking on. Milan Kovac himself admitted that he almost slipped while testing the area where the robot was placed. So if Optimus felt a bit wobbly, that's completely understandable. What was most impressive, however, was that it managed to go up and down the terrain without falling, a feat that deserves further analysis. In addition to its locomotion capabilities, Optimus also has to meet rigorous safety standards, just like any other electronic device. In fact, the requirements for advanced robots are even more demanding, ensuring that they can operate reliably and without risk to users. Tesla has been clear that its goal is not only to create a highly functional humanoid robot, but also to ensure the safety, privacy, and protection of users' data. The Tesla Optimus Gen 3 is designed with a suite of advanced safety features, including emergency stop mechanisms, obstacle avoidance sensors, and an intelligent navigation system that allows it to operate safely in a variety of environments, from homes and offices to factories and busy locations. These systems are designed to prevent accidents and ensure that Optimus can interact with humans without posing a risk. On the other hand, other companies also invest in safety for their robots, but with different approaches. Boston Dynamics models, such as Atlas and Spot, have advanced sensors and sophisticated artificial intelligence to navigate complex environments. However, Boston Dynamics' priority seems to be more focused on performance and versatility, while Tesla places a greater focus on end-user safety. Unitree, the manufacturer of the Go 1 and Go 2 robots, implements basic safety protocols, such as obstacle detection. However, its robots do not have the more advanced protection systems found in Optimus, which may be a concern for those who value safety and reliability. Tesla is already widely recognized for its rigorous approach to privacy and data protection across its product line, from electric vehicles to digital services. The Optimus Gen 3 is expected to incorporate advanced encryption, secure communication protocols, and access control measures to prevent data breaches or unauthorized access. This focus on digital security becomes even more relevant in an increasingly connected world. In contrast, while Boston Dynamics stands out for the performance of its robots, data protection does not appear to be one of its main concerns, since its products are primarily aimed at industrial and commercial applications, where privacy may not be a priority. Likewise, Unitree does not provide much information about its digital security protocols, which may raise questions for users more concerned about protecting their data. Another point that sets Tesla apart is the strict control over who can access and operate the Optimus. The company intends to implement robust authentication and authorization systems, ensuring that only verified users can control the robot remotely. This drastically reduces the risk of unauthorized access that could compromise user security. By comparison, some Boston Dynamics robots, including those used for military purposes, offer greater flexibility in remote control, which could increase security risks. Unitree's more affordable models may require compromises in terms of data protection, which could be a concern for privacy-conscious consumers. Despite the relatively similar price point, the Unitree G1 costs about $116,000, just $4,000 less than the Optimus. There is a significant difference when it comes to safety and reliability. While Tesla has publicly committed to ethical AI development, implementing safeguards to prevent misuse of Optimus, competitors such as Boston Dynamics and Unitree have not made similar statements about the ethics of their robot development. Tesla's vision for Optimus goes beyond just creating a functional robot. It's about ensuring it's safe, affordable, and capable of operating without compromising the privacy or security of its users.